In this video, we'll talk about different operations we can perform on sums that are written using summation notation. So summation notation really is just adding up numbers, so all of our number rules we have for adding numbers apply. However, because of the notation, they may look different, so we're going to go over some of them here. So what's our first rule here? Our first rule is we can add two different summations together. So if we have the sum from k equals 1 to n of some ak's, so one set of numbers I'm adding, and a second set that I'm adding, k from 1 to n of bk, then I can look at adding these two numbers together, right? Because each of these here are numbers. This is a sum of a bunch of numbers, it's a number. Also sum of a set of numbers, it's also a number, so I can add them together. Then if I add k from 1 to n of ak to the sum k from 1 to n of bk, I get the sum from k equals 1 to n of ak plus bk. The basic idea being I can either add up all the a's, then add up all the b's, add them together, or I can go one at a time, do a plus b, a plus b, a plus b, a plus b, add all of those up, I get the same number either way. This also works for minus signs, so I'll make this a plus minus in here. It works the same way. You can also move constants in and out of sums. For any real number c, the sum from k equals 1 to n of c times ak is the same as c times the sum from k equals 1 up to n of ak. This is the normal fact that multiplication distributes over addition written in this notation. Right, c times a plus b is ca plus cb. It's that with the sigma in front of it instead. Another thing you can do with summations is you can shift the index. And why is this useful? This is because this rule up top here only worked because both sums went from 1 to n. If one of them had different values in it, then I couldn't add them together this way. So you can also shift the index. And by that I mean if I have the sum from k equals 1 to n of ak, this is the same thing as, say, the sum from l equals 0 to n minus 1 of a l plus 1 via the relation k equals l plus 1. So what happens is wherever I see a k, I put in l plus 1, so I get that l plus 1 equals 1, and this becomes an l plus 1. And this up top here is really a k equals n, it's where this point stops. So with an l plus 1 equals n, I can then shift everything down by moving the 1, and I get from 0 to n minus 1 of a of l plus 1. This works for any shift you want. If I wanted to make it l plus 5 or l minus 10, I can do that too to work the same way. And there's one other thing you can do, which is sort of pulling off terms of a sum, but we'll see it in the context of the example that we'll do next. I want to find 7 different ways to rewrite this sum here, the sum from n equals 1 to 4 of an, minus sum from 2 to 5 of bn. So one way you can do this is by pulling off terms from the sum. What do I mean by that? Well, I can take the sum from n equals 1 to 4 of an, and I can rewrite this as a1 plus the sum from n equals 2 to 4 of an. All I did was take that first term out of the summation and write it on its own and leave the rest of the summation as it is. I can also write the sum from n equals 2 to 5 of bn as the sum from n equals 2 to 4 of bn plus b5. Again, pulling off that b5 and putting it on its own, leaving the rest still in the sigma notation. And then I can subtract these. If I subtract these, I then get that, the thing I'm looking for, sum n equals 1 to 4 of an minus sum n equals 2 to 5 of bn equals a1 plus the sum from n equals 2 to 4 of an minus the sum from n equals 2 to 4 of bn minus b5, distributing the minus sign through. And I can collapse these middle two together because they have the same indices now. So I get a1 minus b5, grouping that term to the front, plus the sum from n equals 2 to 4 of an minus bn. That's one possible method for rewriting this sum in a way that might be easier depending on what the values of things are. You could also do this with a shift. And so I can rewrite the sum from n equals 2 to 5 of bn as the sum from m equals 1 to 4 of bm plus 1 by replacing n by m plus 1. But now these two have the same indices. So then the sum n equals 1 to 4 of an minus sum n equals 2 to 5 of bn equals sum from n equals 1 to 4 an minus sum m equals 1 to 4 of bm plus 1. Now, the variable used here doesn't really matter. I can just change the m to an n and I don't care about it. So the same thing I can get here, I can write this again as sum n equals 1 to 4 of an minus sum n equals 1 to 4 of bn plus 1, and I combine them together. Sum n equals 1 to 4 of an minus bn plus 1. Another way you can write this expression to make it look a little simpler. Depending on what these values are, what they want to do with them, one could be easier than the other, but this is two ways you can rewrite this using your laws for summations. So that is the idea of what a summation is and what you can do with it, the different operations you can perform on it pretty straightforwardly, as well as how you can manipulate them to make them look better and easier for other things you want to do with these summations.